Hey everyone, today's lesson is on the factor theorem, which is sort of what factoring is all about. Okay, it's kind of the most important thing that factoring is used for. Um, and so you're going to see a little bit of this year, and just know you're going to go a lot more in depth with it next year when you see this stuff. Sorry, I want to get you zoomed in a little bit more here. And so the actual factor theorem we'll get to kind of towards the bottom of this page, but we just have to talk about a couple of things first to kind of work our way up to that. So the first is just a reminder of an algebraic property called the zero product property, which basically says if I give you two things multiplied together and they equal 0, the only way that can happen is if one of these two things is actually equal to 0. So if something times something equals 0, then either A equals 0 or B equals 0. And that is kind of what the factor theorem is based on, but you'll see that as we work through this first example. And then when I use the word 0 in regards to like a polynomial, the 0 is the same thing as like a root or an x-intercept. And it gets its name because it's the value of x that makes the function equal to 0. Okay, so just know that I'm using 0 and root kind of interchangeably here. So taking a look at this first example, it says to graph this polynomial on this particular window and use the graph to identify the zeros. So on here, just so you know, I've already typed in my equation. Oh, ignore that. Y equals, so there's my equation. All right, that's the same thing. I am going to go to the window and adjust the window, and it told me to go negative 10 to 10, but then for y's, I'm going to go negative 50 to 50. And I'm going to graph this thing and take a look at it. Okay, and it's kind of hard to see here because apparently I have my mode set where I don't have my little hash marks here, but I could look at my table and see where this thing, someone's really messing with these settings, where this thing is equal to 0. And I think I'll see it in 3 different places. So I see one here, I see one here, and then there was another one down below. So based on my graph, the zeros, which remember, the zeros are the x values where my y is equal to 0. So my zeros are at x equals negative 4, x equals 0 down here, and then like I said, I know I saw another one here. Scroll, there it is, and x equals 3. So if you were to take any of those 3 numbers and plug them into this function, you would get an answer of 0 back. Okay, and then it says go ahead and factor the polynomial. So going back up here to the original polynomial, I'm thinking about how I could factor that. I would probably start with a GCF, and I think I can take 2x out of there. So if I take 2x out, I'd be left with an x squared and an x and a negative 12, because negative 24 divided by 2. And then this part here can be factored again. I know it's going to be x and x, because that's how I'm going to make my x squared. Because this is negative, I'm going to have 1 plus and 1 minus. And then I need numbers that multiply to 12 and add to make this 1 in the middle. So I believe that's going to be a positive 4 and a negative 3. And then I'm also going to drag my 2x down in front. Okay, so this is factored form. This is me taking this expression and factoring it. Okay, now the question becomes, how do I apply the zero product theorem or the zero product property? Well, remember, the zeros are the places that make this whole thing equal to 0. Okay, I want the x values that make this thing equal to 0. And if you think about this in terms of that zero product property, now I have something times something times something equals 0, which means one of those somethings must actually equal 0. So having my statement written this way as a product, as a multiplication problem, allows me to say this. Either 2x equals 0 or x plus 4 equals 0 or x minus 3 equals 0. And if I were to solve each one of those separately, this one would give me x equals 0. This one would give me x equals -4. And this one would give me x equals +3. Now look at those numbers compared to what we came up with up here. They're in a different order, but we got the exact same values here. So what we just figured out how to do right here in this step is find the zeros to a function like this one without graphing it. And it's not a quadratic, so I couldn't use quadratic formula like I used to be able to. But now I have an option. Ooh, excuse me. Now I can go through and take any polynomial and factor it, break it into as many smaller pieces as I possibly can, set each one of those pieces equal to 0 and solve them. And that gives me my roots of my function. Okay? That's the significant part of this lesson. And that is what's called the factor theorem. So the wording of the factor theorem, of course, if you were to look at it in the textbook as usual, it's going to be longer and wordier. But factor theorem says that C, and C represents a number, is a 0 of P of x if and only if x minus C is a factor of P of x. So P of x really represents the polynomial, right? And then also I want to point out that 0 and root are the same thing, okay? So if you know one of the zeros or one of the roots, you can automatically get the factors. And if you know one of the factors, you automatically can get the roots. And the reason for this x minus piece is you need to be able to solve it and have it come out to be just C. So if I were to set x minus C equal to 0 and move the C to the other side, I would have just plain old C by itself. Okay, so this relationship is a really, really important one in algebra. Okay, we're going to use this for lots of different things. Okay, let's go on to maybe another example here. Oh, left you some space there. So example 2 says find these zeros by hand. Well, I don't really know a way to find these by hand. I don't have a quadratic formula, but I know that I can factor this thing. So I'm going to start by factoring it. I'm going to pull out, let's see, I believe 3 goes into all of these, and also an x to the third. And that would leave me with 2x squared plus 5x minus 12. Okay, just double checking my math as I go there. Okay, and then I want to keep factoring, right? So this is where I'm going to take these, the beginning and the end here. Whoops, ignore that. I get -24. And then I'm looking for things that multiply to -24, add to +5. I'm kind of just running through my list in my head. There's 1 and 24, 2 and 12, 3 and 8, 4 and 6. And out of those, I can make a 5 using the 3 and the 8 if I make my 3 negative. So I'm going to go 3x cubed, and then this would be 2x squared minus 3x plus 8x minus 12. I'm going to group and group. So I get 3x cubed. And then here I'm going to pull out, let's see, an x, it looks like. And then I will have 2x minus 3. And over here I'm going to pull out a 4 and be left with a 2x minus 3. And then when I put this thing into its 2 parentheses, I end up with 2x minus 3 times x plus 4. And then I still have my 3x cubed in front. Okay, so that was factoring. And that was really, that should have been a review of stuff that we've done earlier this week and last week. Okay, this is stuff that you've seen already. So that's why I went kind of quickly through that. Now, the new part is what do we do with that? Well, if I want to find the zeros, I'm really looking for how do I make this thing equal to 0. I'm going to move this up to the top here because I'm kind of out of space. So I'm going to take each one of these pieces and set it equal to 0. So I'm going to have 3x cubed equals 0. I'm going to have 2x minus 3 equals 0. And I'm going to have x plus 4 equals 0. When I go to solve this one, I would start by dividing by 3. So I get x cubed equals 0. Okay? And so really, this is just going to leave me with x equals 0. I want to point out some vocab here that you may or may not need this year. But technically, this x cubed is like x times x times x, right? And so really, any one of those x's could be a 0. Okay? So it's like I have 3 copies of the same answer. So I would say this is x equals 0 with a multiplicity of 3. Okay? It's like I have 3 copies of the exact same answer. And that doesn't matter so much in the graph. You're going to see eventually how that plays into the graph and what it does to it. But it is going to be important later on when we get to some of the harder theorems that involve this stuff. So just like I said, I want to expose you to that word there. Here, I would add the 3 to both sides, so I get 2x equals 3. Divide by 2, and I get x equals 3 halves, or 1.5. And then here I would just subtract 4, and I get x equals negative 4. So my zeros are x equals 0, x equals 1.5, x equals negative 4. Okay. I'm going to leave that there for now. I will pick up with a second video to cover examples 3 and 4. But before you hit that second video, I have some just example questions that I want you to try on your own. Okay, see if you can apply this factor theorem yourself. Okay? All right, good luck.